Good morning and welcome to this presentation. My name is Ravi Narayanan and this is Sarah Ambrose. We are both product engineers in the GeoAnalytics Server team, and welcome you all to this presentation. Before I start, we would like to get a feel for who's in the audience. How many of you are analysts who are familiar with using geoprocessing tools or using spatial analysis in Portal? How about administrators who might be tasked with setting up GeoAnalytics servers? Okay. And anybody already working with GeoAnalytics Server or big data? Okay, thanks. So our goal for this presentation is to introduce to you the GeoAnalytics Server, which was released in 10.5, and provide you with information about the analysis capabilities that are available in the GeoAnalytics Server, and if you are an administrator, how you would go about in setting up a GeoAnalytics Server. With advancements in sensor and related technology, there's large volumes of data that's being collected about various movable and non-movable assets by organizations. And this is a trend that's not going to change. And we need tools for managing such large volumes of data. GeoAnalytics Server is a powerful new capability that was introduced in ArcGIS 10.5 that allows you to process such large volumes of spatiotemporal data using a distributed in-memory compute. If you are someone who is familiar working with geoprocessing tools, GeoAnalytics extends the power of geoprocessing using the distributed analytics and storage. And the results are available as WebGIS layers, which you can easily use in your web map or web app or use it for further analysis. Why do I need a GeoAnalytics server? So GeoAnalytics Server lets you work with large volumes of data, and you can set it up easily with ArcGIS. It's available out of the box with ArcGIS, and you can set it up with ArcGIS components. With GeoAnalytics, you can run data that is too big for a single desktop. For example, jobs that used to take months could be completed in weeks, or job that used to take days could be completed in hours with the power of distributed analytics. If you are a desktop user who is familiar with working with geoprocessing in ArcGIS Pro, you would find it seamless working with GeoAnalytics tools. When you are signed into a portal that has GeoAnalytics server capability enabled, you would see the feature analysis GeoAnalytics tools available in Pro, and you can easily work with it similar to how you have previously worked with geoprocessing tools. Similarly, if you're someone who has worked with spatial analysis in Portal or ArcGIS Online, the user interface that is available for GeoAnalytics will be very similar, and you would find it seamless. If you are a developer who is interested in building a custom application that works with GeoAnalytics tools, the REST API is available for you, and these are geoprocessing services that work in a similar way. ArcGIS Python API is a new functionality that allows you to script analysis and administrative tasks of the GeoAnalytics Server. And let's quickly look at some examples. So this screenshot shows New York City taxi pickup and drop-off locations. These are millions of point data that are represented here. And we cannot make much out of symbolizing these points here. This layer represents the city block groups. With the aggregation tool that's available in GeoAnalytics Server, you can aggregate these points into these block groups, and you can gain insight into both spatial and temporal patterns for taxi pickups and drop-offs. Here is another example. These red dots represents flight data, millions of flight data that is collected over a 1 week period of time. And we cannot make much sense by rendering these points on the map. By using the reconstruct tract analysis tool available in GeoAnalytics, we are able to construct the tracks for individual flight paths. Here what we see is a representation of 605,000 unique flights that are tracked from 100 million points. So you can use the results from GeoAnalytics and either visualize them to find interesting patterns or use it for further analysis. With that, I hand over to Sarah to discuss more about the analytic tools.
So right now I'm in ArcGIS. Yeah. Right now I'm in ArcGIS Pro, and you guys can hear me in the back. Cool. Thank you. I'm in ArcGIS Pro, and I have some data. This is just a sample set of the data I actually have. This one's only 200,000 features that you can see, but already you can see that you can't really understand much from it. The actual data set has 54 million, composed of 273 CSV files. So if I actually wanted to learn anything from this data, I'm probably going to want some way to visualize it first so I can start asking questions about it. So the first thing I'm going to do is I'm going to aggregate points. So here I'm connected to my portal in ArcGIS Pro. So by connecting to my portal that's enabled with GeoAnalytics, I have access to these tools here. Because I don't have raster analysis enabled, I can't see it, but I do have feature analysis and the GeoAnalytic tools. When I select a tool, it's going to open up like a regular geoprocessing tool. You're not going to notice anything different than you would from your normal workflows, except that I inconveniently opened it at the top. So I'm able to fill out the parameters, and I'll open the one that I've already filled out. You're probably wondering what my GeoAnalytics cluster looks like. So I have a 3-node machine cluster. That might sound impressive to you, so I'm going to give you a visual of what it actually looks like. And this is what I'm working on. So this is down in the showcase right now. You may be really jealous and want to steal it. It is locked, unfortunately, so you're not going to take home your GeoAnalytics cluster today. But this is what I'm using right now for processing. So I'm not going to run aggregate points for you, but I'm going to talk a bit about the parameters and show you the results and run a different tool. So here I've added a point layer that's a big data file share, and we're going to talk about this later because this is how I can actually read multiple CSV files at once instead of compiling it into one data set. As you would expect, I create a name for my output, and with GeoAnalytics, since we're working on the portal, that's going to create a feature service layer in your portal. I can then choose to aggregate into bins or polygons. So Ravi showed the example with the New York City taxi data that he aggregated into polygons. Often you won't have a polygon data set to actually aggregate into, so you can create bins that are hexagons or squares, and you can choose the size. So here I chose bins, and I created hexagon bins that were 2 kilometers. I can also choose summary statistics. So I'm always going to calculate the count of points, because that's always going to be something that's pretty important. But you might also have attributes that you're interested in. So here I chose the momentary flag and I created the count, as well as the outage minutes, and I'm calculating the mean of that. So when I ran this tool, it went to my GeoAnalytics server. It didn't just run the tool on this desktop. It went and ran on those 3 machines in a distributed fashion. The results were returned to me, and they looked like this. So that's actually the outage minutes. And we can see that already we're seeing something a bit different than we would expect. There's this kind of warmer area of outage minutes. So with big data, we know that space is really important. So already we can kind of see a trend that we might want to investigate. But we also know that time is really important. So with that Aggregate Points tool, I ran another one using time stepping. And I, again, closed the wrong thing. Oops, sorry. History, close. Here we are, Aggregate Points. So this one I actually used time stepping. So here I have these parameters, and because my data was time enabled, I was able to slice the data into time steps. So what I did is instead of looking at all my data at once, I looked at 1-month intervals. So I'm going to see the first month, the second month, the third month. It's all going to be returned as a feature service, but then I can actually visualize that in Pro with the time slider. Ugh. So here we see I have results. I'm going to enable time on my map. And now I can start time sliding through and actually see how things are changing month to month. We can see that there actually are differences for each month, and maybe we have some kind of temporal trend or patterns that we can investigate. So what I'm going to do is I'm going to create a space-time cube. So this is going to create a netcdf file. It's going to slice it into time and space, but that's going to create a netcdf cube that I can then use in desktop to investigate more trends with the space-time pattern mining tools. So here I've created a model. I'm just going to run create space-time cube, but this is going to use the GeoAnalytics tool. This tool is available in desktop, but sometimes you're going to have data that you just can't analyze on one machine. So we're going to distribute it across multiple cores and multiple machines. When the cube's created, I'm going to run desktop analysis. So in Pro, I'm going to run emerging hotspot analysis. So GeoAnalytics isn't this isolated experience where you run one GeoAnalytics tool and you're done. You're going to continue running other GeoAnalytics tools or desktop tools, because I think there's over 1,000 in Pro or ArcMap that you can actually continue your analysis with. So I'm going to validate it, which I didn't probably need to do, but prove to you that I'm really running it, and hit run. And while I'm doing that, it's going to take a few minutes. I'm going to show you the Portal UI. So we said that you could run this through Pro and Portal. Has anyone actually run any analysis tools through Portal or online before? A few? OK. So is anyone not familiar with Portal at all, actually? Is this a totally new experience for anyone? All right, great. So I'm in my portal, and I'm looking at my content. I've created a folder, and I have a map that I've already created. And it's called Hurricane Tracks. I'm going to open that up in my map viewer. And I'm going to be able to see my hurricane track data. So this is a point data set. Again, over time. We have a time slider in Portal as well. And we can see that we could kind of guess the patterns going on here, like maybe there's a hurricane going here-ish, and then I don't really know where it goes. So how can I actually visualize that? We do have a tool called Reconstruct Tracks, and that's where you take points and turn them into lines sequentially ordered by time using some kind of identifier. So if I hit Analysis, I see that I have standard tools as well as GeoAnalytic tools. Standard tools are those tools that became available in Portal at 10.4, and they're the same ones as ArcGIS Online. When I open it up, I'm able to choose a tool, and it has similar parameters as it does in Pro. I can choose which field I actually want to use for the track identifier. So for example, that could be your hurricane name. So Hurricane Katrina would identify the track. I'm not going to do too many statistics because I'm going to come back and show you one other thing. And when I hit run, this will again use the GeoAnalytics server. I'm not going to run it because I want to quickly finish my space-time cube for now. So I'm going to show you the results that I actually get. So here are those hurricane tracks. So already I'm able to see that I have tracks, and when I look through time, you can see there's some down here in the Indian Ocean as well. It looks like there's more hurricanes, but if you look at the time slider, it's actually 1888, so maybe people just aren't recording it then. We're able to see some patterns. And if there's anything I want you to leave here today, other than the wonderful world of geoanalytics, you're going to learn some hurricane facts. So, if you look here, does anyone see any weird patterns about hurricanes, maybe? Around the equator, maybe? Right, so they're not passing the equator. Does anyone know why this happens? Fun hurricane fact. I have an answer over here. Do you know? Yes, exactly. I spent a bit too much time last night learning about hurricanes, but you'll also notice they're not in the poles, and that's because the water is too cold. Maybe a lot of people knew this, but I did not. So there's also something you can also do with reconstruct tracks that's really interesting. So there we were able to see the tracks, but we weren't able to really learn too much about certain attributes. So if I go back to reconstruct tracks, I have this expression that I can use. So this actually applies a buffer to the input points and then reconstructs the track from that. So if I wanted to, for example, to create a track using wind speed as a buffer, so then I would be able to see where the hurricane was actually had a higher wind speed. I can do that by just adding that as an expression. And to give some exaggeration for the analysis, I could write something like multiplied by 1,000. So each individual feature will be buffered by this attribute depending on the value. When you add that expression and run the tool, you end up with something that looks like this. So you're able to see where the wind speed's actually higher. You see that it starts off a bit slower, increases, and then usually dies down. And go back to the world view. And we get to have these cool centipede effects. So this could be used for something afterwards where you join it to data to see maybe if the hurricane impacted property damage, for example. So you won't just have a line, but you'll actually have this distance that you can use. Let's go back to our pro. And it's completed. So we've processed the 2 of 2 tools. The first one is our geoanalytics, so that's why we're seeing all of these tasks. When we distribute the jobs, we create a bunch of little tasks that are distributed across the multiple cores. So as we complete that, we get a bit of a progress coming back to us. And here I did it just for the downtown Houston area, and we're able to learn a bit more. So potentially if you were this power company, we end up with these areas that are called persistent cold spot. That means there's not going to be that many power outages there. So that's like a good area for us right now. But maybe something where you're having intensifying cold spot. Hopefully that's an area that you've recently maybe worked on, fixed, and now you're seeing that you're now no longer having power outages. We don't see too many intensifying hotspots, which is great at this time. This can be applied to a whole bunch of different applications, obviously not just power outages. With that, I think I'm going to hand it back to Ravi, who will hand it back directly to me actually doing slides.
Okay.
So. All right, so for an actual analytical overview of the tools, so these tools are patterned after the ArcGIS Online tools. So those tools became available in ArcGIS Online, but how those tools were actually decided upon was within Esri, we looked at what are the common workflows users actually do. So we made those the first tools that we exposed to online and then through Portal. When we were choosing our geoanalytics tools, we looked at those tools and said, these are the most common workflows, but which ones actually apply to big data? There's some of them that don't apply to big data, but the ones that we really focused on do. And it's usually summarization and aggregation. I have so much data, I don't even know what to do with it. It's sitting in a huge file system somewhere. I can't even visualize it because it's hundreds of files. How can I start doing that? And it's through geoanalytics. We also know that big data is very important to have temporal. So it's you're accumulating files, there's some kind of temporal aspect. So we want to do spatial as well as temporal. When we're doing temporal analysis, there's going to be 2 different ways we can represent time. There's an instant, so just one moment in time, as well as an interval, so a start and end time. These are the actual tools that we have for 10.5. So I believe there's 11 tools, mostly focused on summarizing, as I said, so aggregating points into polygons or bins. And I think this is going to be a really popular tool when you just start out. So you have a whole bunch of data. This is the first thing you go to start visualizing and seeing what you want to do next. Joining features, and I'm going to go a bit into a few of these tools more. I think joining features is a really powerful tool because it's your spatial join as well as a temporal join and an attribute join all in one. You can do one of those, you can do two, you can do three, or any combination. Reconstructing tracks, which I just showed you. Summarizing attributes, so this is a tabular result, and you're just summarizing on some attribute to compile your results. Summarize within, summarize points, lines, polygons within another polygon data set. Find similar locations. So maybe you have a billion features, and you have one that you know you want to match to. How can you find the 10 from that billion most similar based on attributes? Calculating density, visually similar to aggregating points, but you're looking at a neighborhood and actually dividing by the area. Creating space-time cube, I showed you that. So those space-time bins, and then that's really powerful because there's those space-time pattern mining tools that you can then apply afterwards. Finding hotspots, Lauren showed this at the plenary with that same power data, and we were able to find statistically significant hot or cold spots of our data. Creating buffers, if you've ever used a GIS tool, it was probably this one. So that's what we're doing. We're just creating buffers on input features and then copy to data store. So our data is stored in what we call the ArcGIS data store. And this just moves your feature service from the spatiotemporal to the relational database. I know we haven't talked too much about that, so don't worry about it. But it's just depending on the capabilities you want to do with your service afterwards, you might move your data around. I'm going to go a bit into the analytical details, some of which we covered. So aggregating into polygons that we saw, target features and join features. So I have all of these points. I want to aggregate it into these polygons, and I get the final result. So here we can see, based on the number of points, what's the color of the polygon. And this is, if you go and count the points, this is a real diagram, so it will work out. You can also do that into time steps. So I showed this with the power outage data. We have our polygons, but we have points in time. So I'm going to create those polygon bins at each time and only count what's in there in space and time. And that's when you can start using the time slider, visually looking and seeing what the differences are between time. You can also do that into bins. So there's square or hexagon bins, because you don't always have a polygon data set. You maybe don't even know where your data is. You're just guessing. You want to be able to visualize it. So I do have an example. So on the bottom, sorry, is the create space-time cube graphic as well, which is the space-time bins in a netCDF format. So I want to show you a bit about aggregation, some examples using lightning strikes. So here we've aggregated lightning into square bins. We could also do it into hexagon bins, as well as a polygon data set. So square, hexagon, polygon, what you use is depending on your data. If you have a polygon data set you really need to aggregate into, at the showcase I had a lot of people say, I have my own data set, can I do that? Yes, of course you can. You can aggregate into a polygon. For hexagons and squares, that's personal choice. If you think about a soccer ball, it's not composed of squares. It's not really composed of hexagons, but more hexagonal. So that's going to fit your globe better. That's why we really go with hexagons. It's not just because it's super popular on Pinterest right now. More the soccer ball. So we can actually do it with time steps as well. So I showed you the images of lightning strikes, but this is with 6-hour intervals. So this is what it looks like for the lightning strikes over 6-hour intervals aggregated into square bins. That same thing can be applied to hexagons. And again to polygons. So we're able to see those lightning strikes move through. I talked about time stepping, and I only did that example of, I believe, 1 month. But you can also do much more powerful things using 3 different parameters. So the one I used earlier was the time interval. So that's the duration of the time step. So when I did 1 month, that was the time interval. But you could do something like a repeat as well. So how frequently do you do that time step? So if I did 1 month, I could say that I only want to measure that 1 month every year. And that would be the repeat 1 year. And the reference time is how you align it, because you don't want to just send it off and it's just going to start the time interval whenever. You can choose when to align it. So maybe you want to align it on a Monday at 8 a.m. Or maybe you're just looking at weekly data, so you want to do Monday at 1 a.m. all the way till Friday, and just skip looking at the weekend data. So an example of that, if you wanted to do just hourly steps, you would just say the interval is 1 hour. If you wanted to look at every 12th hour for some reason, you might do the interval is 1 hour, and you repeat it every 12 hours. And if you wanted to do every Monday, you would do an interval of 1 day, a repeat of 1 week, and you would set your reference to some Monday. So I'm not going to make you go back all to the Monday, or to the Monday that you want, so you're not going to have to go find Monday in 1960. If you set a Monday, we're going to go forwards and backwards so that it's much easier for you. So we're just creating slices the whole way, and whenever there's data, that's when it's included, which you can see in the example here where we have 1, 2, 0, 0, and 1. That's counting the red points that are actually within that time interval. So I mentioned join features earlier, and that's where we have the spatial, temporal, and attribute join. So here I have my target features, which are the features that will have attributes joined to it. They're polygons, and they're intervals in time. My join features here are point data sets, or as a point data set, that's an instant in time. And when I actually get those results, I end up with the polygons, where the points were within in both space and time. I do this example with points and polygons because that's usually the easiest to understand, but you can do points, lines, polygons in any combination, as well as intervals and instants in any combination. I believe there's about 12 relationships for the time step, or the time joins. So there is a whole bunch you can do. You could do something like a point near another point within a week. And again, just to show that you can do it the other way, you can have a point data set where you're joining the polygons to, and you get the resulting points. Reconstruct tracks we showed, but here's just a diagram. So we have the purple and blue points sequentially ordered in time, and they're automatically based on the color here. So blue or purple would be the track field name. We're able to order them in time. So they end up as an interval. So they started out as instant points, and then the interval is represented by this first point, which is the start time, and the end time, which was the last time in the track. So what data can you actually use when you use geoanalytics? So you can use your GIS data that you already have. So if you have feature services, that's a great input. That's what you can use. Anything in your WebGIS that is a feature. Again, this isn't, so we didn't really say it, but this isn't raster analytics. There is a different product just for distributed raster analytics as well. And then you can also use your own big data sources. So I mentioned earlier that the power outage data I had was composed of 276 CSVs. That's because we have something called a big data file share. So a big data file share is a way we can easily attach folders on a local disk or a network share. You can also connect data stored in HDFS or Hive. So we're able to use those other big data solutions as input. The actual output is going to be a hosted feature service. So you're going to see a feature service created in your portal. You're able to use that feature service for whatever you want to. You can bring it back into Pro. If you really wanted to bring it into ArcMap, you could do that, continue your analysis flow there. You could share a web map. You could do anything that you really want to with your ArcGIS platform. There's also the netcdf file. So when I create a space-time cube, that's saved locally as a netcdf file. I have this picture over on the right with lightning data. So lightning is a folder, and underneath it there's 12 shapefiles. So when I register this, all of those 12 shapefiles are going to be read as one data set. If you gave me 12 more shapefiles tomorrow and I analyze this data set, it's going to include all 24 of those. So you can just keep adding data as it grows. There's nothing you need to change on the server. You're just going to browse to the same thing. So I'm going to show you registering a big data file share instead of this screenshot. All right. So here I am in my GeoAnalytics Server Manager. When I go to, and normally you'll open to the services page, which now I'm regretting pushing. Okay, I didn't really push it. I did. So we're at our site, and if we just go to data stores, we're able to register a big data file share. So what this data set actually looks like, what I'm going to register is this folder here. So I'm going to register C data, and what it's going to do is it's going to go and look at every folder underneath it and name that as a data set. So I have data here, and each one of these is going to show up as a data set. So we should end up with 9 data sets. Underneath that, you could have a whole folder structure. It won't matter. It will use that data, whatever's underneath it. So power outages, it's going to read all of these data sets as one. So let's show you what that actually looks like. So live demo, just to jinx it. And then we're going to see data, because that's where it is. And so now it's going to register. It's validating that I can access that path, and then it's going to generate a manifest. So if I hit this button here to edit it, I'm going to get a little prompt saying your manifest is being updated. So what's happening now is we're checking each of those data sets, and we're trying to guess the schema. So what fields represent the time, what fields represent the location, time, date, location, as well as what the other fields are. Because to actually run these in the tools, we have to have an idea of what fields we have, what types of fields they are, so we can choose the right analytics. And I think, there we go. So I'm able to open up. I see that I have 9 data sets in the big data file share. And I'm able to select a data set and look at the info if I want to. So I can see this one's a shapefile. It finds the spatial reference. You can look at the fields. You can see which are geometry and time related. You can also go to the Advanced tab. Because it's Dev Summit, I will. I didn't make any changes, so don't worry. I can hit Manifest, and I see that it's a JSON representing each data set. So if we look at power outages, for example, we can see we have our power outages data set here. It knew that it was a delimited CSV file, and here's all of the fields that are in that data set. When we go to the bottom, we can see that it recognized the geometry as type point, as well as the fields that represent the X and Y, so latitude and longitude, and the time field. So it picked restored time. It used just a keyword, so it looks for time and date, X, Y, latitude, longitude to determine these fields, and it knows the format of the time. So when I run this analysis, there's already a time field registered. I can do any time stepping or temporal joins that I want because of that. When I created this, it actually created an item in my content, and that's how I can browse for it. So if we go to admin, here it is. The live demo one is right there. And again, because it's a developer summit, I'll show you the REST endpoint. So if you are running your tools through REST, is anyone going to be running their tools through REST at all so that they can okay, great. So that's how you would programmatically access it right now, as well as the Python API. If I view that URL, there's all of my data sets. And this URL is the input. So instead of using a feature service, this is what I actually use. And that was the big data file share. And then we're going to go back to Ravi for some GeoAnalytics Server setup, as well as deployment patterns.
Yes. Yeah. Thanks, Sarah. So we're going to look at how you can go about setting up GeoAnalytics Server and also some deployment patterns. So if you want to set up GeoAnalytics Server, earlier we had mentioned that it is readily available out of the box and can be set up using our ArcGIS components. And these are the components that you would require for setting up GeoAnalytics Server. Portal is the web front end for the ArcGIS Enterprise. And many of you already mentioned that you're familiar with Portal. ArcGIS Server is the engine that powers the services and the analytical tools for your ArcGIS Enterprise. And so we will be setting up a hosting server and a GeoAnalytics server, both coming from the same ArcGIS server setup. ArcGIS Data Store is a ESRI provided storage for the data that you publish to Portal. And there are 3 types within ArcGIS Data Store: the relational store, spatiotemporal store, and tile cache. And for the purpose of GeoAnalytics Server, you would be installing just the relational and the spatiotemporal store. ArcGIS Web Adapter is ESRI provided load balancer or a reverse proxy that you would be configuring with your Portal and server. So to set up a GeoAnalytics server, you start with an ArcGIS Enterprise deployment. Many of you who have worked with Portal might already have this, but I will still go through the steps for installing ArcGIS Enterprise deployment. So you first install Portal and your ArcGIS server, and you license it as a standard or advanced GIS server. And you would install ArcGIS Data Store. Install 2 web adapters, one for Portal and one for the server, and configure the web adapters. You register the relational ArcGIS Data Store with the server, and then you federate your server with the Portal and configure that as the hosting server. So with this, you have completed the ArcGIS base enterprise deployment, and this is on machine 1. On a second machine, you would install ArcGIS Data Store and then register that as the ArcGIS Spatiotemporal Data Store with the hosting server. So now we have registered 2 types of data stores, both with the hosting server, and this is on a second machine. Now we're going to the third machine, where you would install ArcGIS Server and license that as the GeoAnalytics Server. The setup experience is the same as installing ArcGIS Server. There is no difference. The only difference here is how you license it. So you license this as an ArcGIS GeoAnalytics Server, install web adapter for the GeoAnalytics Server and register that. And then you federate this GeoAnalytics Server with the Portal and configure that as the GeoAnalytics Server. The user experience for federation and configuring the GeoAnalytics Server is same as for the hosting server. It is all done through the Portal Home App organizational settings page. So now we have a system, a 3-machine system that is capable of performing GeoAnalytics. So what we saw now is a simple deployment with 3 machines, where on machine 1 we have the base enterprise, ArcGIS Enterprise. On machine 2 we have the Spatiotemporal Data Store, and on the third machine we have the GeoAnalytics Server. And to the right you see a big data file share that is attached to the GeoAnalytics Server. This is the big data file share that Sarah talked about earlier, which could be your HDFS or Hive or a collection of files that reside in disk. Here we are showing a multi-machine deployment. The only difference here is I've added additional machines to the Spatiotemporal store and the GeoAnalytics Server. And you may want to do this if you want to have additional compute capacity and also storage capacity. And it is easy to install additional machines with ArcGIS Server and add it to your GeoAnalytics Server site. It's the same experience as joining a machine to ArcGIS Server. System requirements. System requirements for GeoAnalytics Server is same as for ArcGIS Server or Portal, because those are the components that we are using. And GeoAnalytics Server is supported on Windows and Linux and on Amazon and Azure as well. And you can use CloudFormation templates or Cloud Builder to easily install GeoAnalytics Server on Amazon and Azure. For the base ArcGIS Enterprise deployment, the minimum recommended resources are 4 cores and 16 GB of RAM. And for the Spatiotemporal Data Store, requires a minimum of 32 GB of RAM. And you should also consider having a disk that's fast and also sufficient disk space depending on amount of data that you want to store on the spatiotemporal store. For the ArcGIS GeoAnalytics Server, we require a minimum of 4 cores and 16 GB of RAM for each machine. And again, sufficient temp space on the drives where the temp data will be written. This is especially important for Linux, where the defaults might be configured with a lower temp disk space. In this diagram, what we are seeing is the inputs and outputs. Sarah talked about that earlier. So GeoAnalytics Server supports inputs from hosted feature services that are in your portal, as well as big data file shares and feature services that come from other servers. When the data is from a hosted feature service that is on your own portal, GeoAnalytics Server is able to read the data directly from the database. And that performs better compared to feature services that come from other servers where the data has to be downloaded via query. In this diagram, you see these multiple blue lines that go from the GeoAnalytics Server to the data store, as well as when reading the datasets to the GeoAnalytics Server. What that represents is GeoAnalytics Server does the distributed processing of data when it is reading as well as writing the data. Just to stress that point, we have shown that here. The results from GeoAnalytics are written to the portal as a feature layer, and the data for that is stored in the spatiotemporal or relational store. One additional consideration that you want to have for the big data file share is you should locate that. You should not locate that on the GeoAnalytics Server machine itself. You should try to locate it on a machine which is other than the GeoAnalytics Server, because when the data is read in parallel, it's going to consume disk I/O resources on the GeoAnalytics Server and could compete with your compute resources. With that, we come to the end of this presentation. We want to summarize a few things. One is ArcGIS GeoAnalytics is available out of the box, and it is ready to use with your ArcGIS Enterprise. So it is easy to install and with familiar ArcGIS components. GeoAnalytics Server does distributed analytics and provides you with powerful tools to analyze large volumes of data in a short period of time. And the results from GeoAnalytics lets you see big data picture in a clearer and more meaningful way. With that, we open up for questions. Are there any questions? Yeah.
So,
in the back.
so portal is a must for this, right? I mean, I'm new to this kind of GeoAnalytics, so it's if we don't have that has to be part of the traditional way around.
Right, so the question is Portal a must for GeoAnalytics? And yes, it requires ArcGIS Enterprise, so only available at 10.5. Enterprise comprising of Portal, ArcGIS Server and Data Store, and then your additional GeoAnalytics Server.
And you can only reach the ArcGIS Pro or the Portal Map View or the REST API, but ArcGIS Desktop can't directly.
Right, ArcMap you won't directly be able to run tools. Pro is the preferred desktop client. Yeah?
Can you have both the GIS server role and the GeoAnalytic role installed in the same server, and whether or not it is a recommended thing to do?
Yeah, so the question is, can you have your GIS server and your GeoAnalytics server installed on the same machine? And Ravi, do you want to answer?
Yeah, you can.
Technically.
But, technically you can, but you have to be aware of the resource requirements for the GeoAnalytics Server, as well as the Spatiotemporal data store and your base ArcGIS Enterprise. So if your machine is capable of supporting it, you could have it, but the recommendation is to have them separated in 3 machines. Yeah.
You're also purchasing each separately, so you'd be paying twice on the same machine. So it's probably worth buying an extra machine if possible. Yeah?
Are all those GeoAnalytics analytical tools also available on ArcGIS Online?
No, this is only on-premise at this point. So you have to have ArcGIS Enterprise, and it's not available in online. Those standard tools that I showed quickly in the portal UI, those are the ones that are available online, but not the distributed processing at this point.
Each time when I run the GeoAnalytics, will it generate a new feature layer or it will go into our existing?
Right, so each analysis, did you say each analysis, will it create a new feature layer? Yes, every analysis will create a new feature layer, except create space-time cube, which creates a net CDF, but that would be unique in your organization. Yeah?
Why did the GeoAnalytics have its own web adapter? What's getting that?
Yep, so I can show you again, because it's a different server. So what I like to do personally is install all 3 web adapters on the same machine, so I always have the machine name, and then I have a different web adapter. So if you look at this, my web adapter here is GIS for GeoAnalytics Server, and that's because I have to access Server Manager individually from my GIS server. So any analytics that I run, I'm using this one as opposed to, oh, sorry, let me fix it.
Yeah.
I thought it was switched.
Okay.
All right, so thank you for letting me know. So this is my GeoAnalytics server. GIS is my web adapter. My other server is just my GIS hosting server. So all of the analytics have to be run through GeoAnalytics. And since that's a separate server, it's easiest to have a separate web adapter for it.
Yeah, the reason.
Exactly.
Yeah, the reason is, the clients have to access the GeoAnalytic tools, and that is through the web adapter, not through the private URL.
Yep.
There was a tutorial before on GeoVent and Spatiotemporal big data, and about 2/3 of that was certificates. Is there a similar process of getting the certificates right across all this data?
Yeah, so the question is regarding certificates and what is the requirement when installing for a GeoAnalytics server. The requirements are the same as when you're installing Portal and ArcGIS Server. It's the same requirement for GeoAnalytics Server as well. It is not any different in terms of certificates.
Yeah.
Is it possible to write custom
Is it possible to write custom tools? At this point, no. You're left with chaining the tools that are currently there, working towards a developer API in the future, but right now it's through REST or the Python API.
Okay.
When would you recommend copying the data to the file shares? I mean, not the file shares, the spatiotemporal big data store.
Right, so when would we recommend copying the data to the spatiotemporal data store? Do you mean results, like the copy to data store tool?
I thought there was a way to load the data into.
Yeah. So the question is, when would you recommend copying the data to the data store, the spatiotemporal data store, right? So there are a few cases where, one is if it is a feature service that is not on your hosting server, but if it's large amounts of data, you could bring the data into the spatiotemporal data store so that the performance for analysis is better. When it is a data that is a service that's outside the portal, data is going to be downloaded via query, and it is much easier to work with data if it is in the spatiotemporal or the relational store. The other, are there any other cases you can think of?
I would think that a case that people seem to like to do and might not be the best all the time is if you already have a big data file share, you don't need to copy it to the data store to run analysis. If it's in a big data file share, you can just use that as an input for your tool like Aggregate Points. So some people are like, I have a big data file share with 2 billion points and I want to visualize it. You can't visualize a big data file share because that's locally stored on your machine. So a lot of people want to copy it to a feature service. That's probably not ideal because you're not going to want to draw 2 billion points anyways. So that's more about when you shouldn't. I know people are excited to copy it to the spatiotemporal data store, but usually you want to think about what you actually want to do long term before you do that.
Do we need the knowledge of Hadoop or Hive?
No, you need no knowledge of Hadoop or Hive. Some people won't even use a big data file share. That's just one way we can get data in. Yeah.
Just to get that right, if I have the data in Hadoop and access via Hive, I do not need a copy in the spatiotemporal data store. I can directly put it through big data analytics.
Right. So the way I registered that big data file share, that was a folder. So I went to big data file share and I did type file share. You can just choose Hive here and you can fill out your Metastore URIs and connect that way. And that's your input for analysis.
And that's directly the endpoint. Okay.
It seems like this introduces a lot more moving parts compared to just running it on a single desktop machine. So I'm wondering if there's any kind of analytics there, tuning something like system monitoring, for example. If there's any specialized parts of that for this deployment.
Can you be a little louder? We couldn't hear the everything.
If you compare it to a single machine, there's a lot more moving parts involved in this. And so, as one of the benefits that you mentioned is speed, improving speed, you might want to repeat jobs. Are there any specialized tools for tuning this deployment?
Are there any specialized tools for achieving this deployment of?
Esri System Monitor will allow you to tune your ArcGIS server.
Right.
Is there anything in there that's dedicated to this?
No, we don't have any tools for tuning the GeoAnalytics server at this time. There are a few settings that you need to do for the GeoAnalytics server. We didn't go into the detail, but if you're interested, if you stop by the GeoAnalytics server island, we could discuss that. Since you are in manager, maybe we can quickly show that.
So this is services in my GeoAnalytics Server Manager. If I go to System, it's going to list all the toolboxes that I have. And when I go into GeoAnalytics Tool, there's specific settings just for the GeoAnalytics tools under Parameters. So these are two parameters that we set just for GeoAnalytics. There's the max allowed compute cores per job, as well as the max allowed memory per job. Memory per job per machine.
Per machine.
Yes.
So depending on how many machines you have and how many cores, you will have to adjust these values so that GeoAnalytics takes advantage of those.
Yeah.
I know the roadmap of GeoAnalytics roadmap.
A roadmap of GeoAnalytics. So right now we're working on 10.5.1. So 10.5.1 is mostly focused on increased performance. 10.6, or next release, I don't know if it's named that, we're going to be focusing on new analytics. We're still working on finalizing that. Summarization and aggregation is still really important, but also looking towards predictive analytics in the long term.
Which version will have more GeoAnalytics tools? Which version will more?
Which version? 10.6 should have more tools, but not finalized list yet. Any more questions? Feel free to come up. We'll be here for at least 5 more minutes, and thank you so much.
Thank you.